I recently found a terrific live data feed I want to play with. It's the GitHub firehose. You can actually tap into GitHub and get JSON data for every event that's being generated, which I thought would be fascinating. There must be interesting data sciencey patterns we can pull out of that, which will be really interesting if you're interested in the behavior of programmers, and I certainly am. And then I took a look at it. There's actually a web page that shows you a summary. And I thought, well, yes, that's going to be interesting data to process, but it's really busy. Maybe first we should talk about using Python to get this data, stick it in Kafka, and actually stick it in Kafka with enough performance to cope with a feed this busy. So that's what we're going to do. In this video, we're going to go from scratch, server-sent events with Python into Kafka, and we're going to talk about optimizing that pipeline. The things you can do to make the out-of-the-box performance of Kafka producers much, much faster, relatively easily. So let's get started. I'm going to start with the scaffolding. If you've seen a few of the videos in this series, chapter markers below. But if you're still with me, I've got an empty directory, and I'm going to set up a Python environment using the module virtualenv. And I'm going to source env bin activate. Now we're in an isolated Python workspace. I'm going to do pip install, and I want two libraries for this project. The first is quick streams, which is my Python to Kafka library. And the second is that GitHub firehose is a real-time feed using server-sent events. It could be using WebSockets, pros and cons to each approach, but the difference is very minimal. The point is, it's a live feed that I can get with this protocol instead of polling an HTTP endpoint. This is much nicer. With those two in place, I think I will create myself a main.py file and stick in my usual scaffolding. So def main logging.info start, so I can see the script has actually started. That makes me want to import logging. And I shall invoke the ancient mantra. And call main. And I'll just set logging's basic config to level of debug. That is my opening stanza of the poem, Python, How I Love Thee. Right, let me source my virtual environment in another window and just check that works. It does. Okay, I know how to program Python still. Good. Right, what's the first step? First step is to connect my server-sent events library and start getting this data. And it's actually surprisingly easy. This library is quite nice for doing it. So if I say from requests SSE, import event source, and then I can create an event source object with, back over here, the URL is, it's just here. That's what I want. That is a JavaScript snippet, but we're not using JavaScript. So we'll just reuse that URL. And you can set a timeout on this, which is probably a good idea. Exit if you haven't heard anything for 30 seconds. So that gives you an event source, which you're going to use and do some interesting stuff, and then say event source.close to tidy it away. That's what you would do in many languages, but this is Python. That's not how we do acquire and tidy up afterwards. We do it this way in Python land. We say that. And then we don't have to call close manually. The with block will call it for us. Good. How do you use an event source from this library? It is super easy. Event source is an iterator. So you can just say for event in event source. Could not be easier. And then you can say logging.info got one of those events. And we'll just do that and take a look. So let me clear the screen and run that. Oh, there you go. There's plenty of data. Firstly, wasn't that easy? That's like 17 lines, and we've already got the data coming through. If I kill that off, we can have a look at it. Look. So you get a message event that has a type of event, that's not too interesting, and it has some data, which looks to me to be a JSON string. So let's handle that a bit more neatly. If I say my value that I'm interested in is the event.data, that's a JSON string, so I could call JSON load as string. And then I could print that to the screen. I'll import JSON. And if I wanted something slightly nicer than that, I could say from pprint import pformat, go down to the value and say pformat that value. So event data is a JSON string. JSON.loadString turns it into a Python dictionary. Pformat turns that back into a string with neat indentation. So the effect we should get is this. Now I can actually make some sense of the data I'm getting. Let me kill that off. I'm just going to handle that keyboard interrupt because that's bugging me. Let me put a try block in. When I say I'm going to handle the keyboard interrupt, what I mean is I'm going to ignore it completely because I don't care. Like that. Now if I run it and kill it, yeah, it closes cleanly. You see, even though I'm killing it, it is tidying up that connection to the firehose, which is exactly what with is for. Good. Right. Should we have a look at these events? They all have a similar top-level structure. They've all got an actor, which is who caused the event. They've all got an ID, which is a number. They've got a payload, which varies based on the type. So for this, I'm going to store this in Kafka. So at the moment, I'm just thinking about having a key and a value. And I think my key should be the values ID field. That will do for now. Now we can talk about getting that data into Kafka. So I usually say I've got a Kafka broker running locally, but this time I think I'll show you how I'm doing it. This is one easy way you can run one. So there is a quick command line app you might want to download. And it does lots of interesting things, and it's really large enough to be its own video. But one thing I've been using it for is if you've got a Git repository, which you can just create with Git init, and you say quicks init, that will create some stuff. And like I say, it's a separate video to explain it all. But the default quicks.yaml has just enough stuff in it to say quicks pipeline up. And that will create the right Docker Compose file and start it running such that you've got a broker running locally and you don't have to worry about configuring it. It's just there on port 19092. So let's write the code around that. If you've seen the other videos in this series, this will be familiar. We're going to import QuickStreams application object. We're going to create an application object here. And we're going to give it that broker address, which is localhost 19092. And I always set the log level to debug, at least in development. And then we want to create a producer, a write-only connection to Kafka. And echoing back to earlier in the video, we could say our producer is app.getProducer and do some stuff, and then remember to call producer.flush at the end to make sure that everything we think we've sent has been acknowledged by the broker. But that's not how you do acquire, use, and release in Python. As I've said, we use with syntax. That's the way we do it in Python because it's easier and safer and more reliable. And it's less code for us and more intelligence that the library writer can add in. So we kind of want this. Yeah, that's one way to do it. However, since I think Python 3.10, you've been allowed to merge these two blocks in brackets. You can just say that with brackets, the different things you want to acquire, bound as variables, do this. So I think that's the right way to write that code. With that set up, we can think about sending the data to Kafka with producer.produce, which in a parallel universe is called writer.write. Semantically, that's what it is. Produce it to the topic GitHub events is as good a name as any. The key is the string which we've already got from the ID. The value also needs to be a string or bytes-like object. So I need to take my value dictionary and reserialize it as a JSON string. If I do that and run that, it's tough to be certain that's working. I think it is, but let me just do this. So I don't think we need to be quite as chatty. Let's do logging.debug there. Let's change my logging library's debugging level to info. Rerun it. Now it should be much quieter. And the way I'll check it's working is to pull out my old friend kcat. Tell it that my broker is running on localhost 19092 and consume from my new topic GitHub events. And let's see what it says. Yeah. Okay, that is definitely being written to Kafka. One tip with JSON data, if you pipe that onto JQ dot, you can see it pretty printed. So I'm definitely downloading and storing lots of interesting JSON data. But am I doing it efficiently? That's a great question. Let's look at storing data in Kafka efficiently. And the first rule of efficiency is before you try and optimize it, make sure you can measure it. So let's talk about how we're going to measure the performance of writing data into Kafka so that we can talk about making it better. I am going to add a few extra producer parameters under producer extra config. And the first one is I'm going to say to the Kafka library, every 5 seconds, I want you to give me some statistics on how it's been going. I want a quarterly employee report. I want you to say, give me some statistics on an interval of some number of milliseconds and report to me how many events you've published to Kafka and what the details are of that. And if this were going into production, I would probably choose a figure like every 5 minutes to report. But since we're doing it as a YouTube video, let's make it every 3 seconds, just so we get some feedback quickly. So statistics interval milliseconds says how often it reports a summary, and stats CB is the handler that gets that summary and is allowed to process it. Why one of them is statistics and the other is stats, I don't know. Don't ask me. I didn't create the names. So I need a callback function. And that callback function is going to take some kind of stats message and let's just take a look. Logging.info stats is a stats message. Should we have a look at that? Every 3 seconds, we should get an update on how it's been going. There we go. It's another JSON string that I can't easily read. We already know how to deal with those, don't we? Let's go into here and say the stats object is JSON load from the string stats message. And we can p-format that stats object to get it pretty printed and start making some sense of it. Dun, 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 dun. Wait 3 seconds, and there we go. So have a look at this. This has lots of interesting data, more than you're going to initially want to try and parse. The thing I want to draw your attention to is under topics, you'll get a dictionary of all the topics this program has dealt with, just one in our case, and it will talk about batching. So that leads us into talking about batches in Kafka. And the way to understand batches in Kafka is, have you ever gone to Amazon and ordered like 2 memory cards and a toothbrush, and they send you 3 big individual boxes with 1 item in each? And you think, why didn't you just put the 3 things in one sensibly sized box? That would have been so much more efficient for everybody. That's the way batching works in Kafka producers. Every message you send actually gets put in a box, and the more messages you can get into a single box, the more efficient the transfer will be. So if I have a look at these statistics, it's telling me that in my 3-second window, on average, I put 6 messages in every box. I packaged together an average of 6 messages before sending it over the wire. And the average size of each batch, the average size of each box, was about 25 kilobytes. There's an overhead for each batch you send, and there's an overhead for each batch you store. So what you really want to do is get that number nicely high. What's high? Glad you asked, glad we're measuring, because that's a very good question. So let's dig in a bit deeper. Those are average statistics for every 3 seconds. The other thing you can say is you can set a low-level debugging flag to message, and that will give you individual message batch stats, which is useful. You can also set this to all, just so you know, and you'll get even more low-level Kafka information. But for this video, we just need message. And let's run that, and I'll show you what it says. So this is giving us information about individual batches that have been produced. And if you look at this line here, it's saying that this message set, this batch, contained 3 messages. That's not many. It's about 50K. This one had 3 messages, 5. We're averaging 4 or 5 messages a batch. So let's talk about how we get that number up and why I think it's too low with a parameter called linger.ms. And the way this works is the same intuition as Amazon parcels. If I've ordered 3 things and they're available now, I'd like you to send them all in one box. If one of them is going to take a month to show up, well, I'd rather you sent me a box with 2 things in and I got some of my stuff right now and then waited for the 3rd thing. So the question becomes, how long do you wait around before you say, this box is as full as I want it to be for now? That's what linger.ms is. It tells the producer, don't send stuff straight away. Don't send the batch the second you've got some information. Wait for some number of milliseconds before you say, that'll do for now, ship it. What's a good value for this? It depends. All this stuff depends. If your application generates a single message an hour, you're just going to have to resign yourself to all your message batches containing a single message. Having a look at my data source, I mean, I think we're getting 50 to 100 messages a second. So something sub-second will make sense. I'm going to say 200 milliseconds. Cognitive psychologists will tell you that 200 milliseconds is about the time it takes a baby to recognize a picture of their mother. And so 200 milliseconds is kind of brain fast, but computer slow. So I like that number. This will give us roughly long enough to start filling the boxes, but won't really introduce any noticeable latency. So I feel good about that. Let's see what effect it has on the code. We were doing 4 or 5 messages per batch. Now I'd say we're doing, well, there's a 40, 36, 34. What do the stats say? We're averaging 33 messages a batch. That suddenly jumped up. That's going to be much more efficient. We could push it higher, but already we've got around about an order of magnitude more efficient box packing just by tweaking that number. What would happen if we turned that up to something that does introduce latency? 200 milliseconds. Let's rerun that and see what the stats say. We are getting about 100 messages in a batch, give or take. 111 for that one. So that kind of gives me a sense of how busy the source is. There's no point going a lot higher than that because clearly I'm not getting more than about 50 or 60 messages a second. So why don't we stick with half a second? 500 milliseconds. That feels like about the right trade-off for performance versus latency. For this particular application, always check the label. Your mileage may vary. Okay, what else can we do? Well, the other interesting control for Kafka batch efficiency is, have a look at this. This message batch had 51 messages and was about 130 kilobytes, give or take. I can't divide by 1,024 in my head, and neither can you. And if you can, get in touch, because I'd love to know how you learned to do that. Let me show you this control. And this is going to win my award for the most sensibly named Kafka configuration parameter. It's batch size, which sets the size of a batch. Maximum size of a batch in bytes. Let's see what happens if I set that to 1. So my maximum batch size is a single ASCII character. What will happen? I will, look at this, all my batches are now down to a single message. So that's the first thing to understand about batch size. Setting it too low doesn't break things. It's that once the batch gets that size or larger, we close it off and ship it. So with a size of 1 byte, you are going to get 1 message at most in every message set, in every batch. And looking at that, I think the average size of a message is about 3 or 4K. So that gives me an idea of what I want to actually set this to. I would like 3 or 4 kilobytes times, what did we say, about 50 messages? I might set that a bit higher. So maybe I'll say a 5 kilobyte message and I can handle 100 of those. So 500 kilobytes, I could actually go up quite happily to a megabyte for this. That feels good. A megabyte is the maximum batch size. Let's run that. And you see, there's no correct value, and that's why they're not set by default. But you can start to build up some sense for your domain what the right values might be. That feels like we're producing an appropriate number of messages in each batch for the speed with which data is coming in. If I were connecting to a firehose that did 50,000 messages a second, I'd definitely have different numbers. Kafka could handle those numbers, but I would tune it differently. Okay, good. One more parameter I want to show you for efficiency. Have a look at some of these messages here. Maybe you've spotted it if you're hawk-eyed, but in this debugging message, if you look at the end, it says uncompressed. And if there's one thing I know, it's that JSON data and all readable strings really compress really well. So what we can do is get the producer to compress each batch before it sends it. And it will send a compressed batch over the network. The broker will store a compressed batch on disk, and it will send the compressed batch to the consumer when it's read. So you'll save time and money on network bandwidth and storage costs. And given how well readable strings like JSON compress, you might save as much as 10 times just by setting compression up. So how do we set compression up? We first are going to look at, when we first start up, here in the debugging messages, it's going to tell you what features this producer supports. And it supports lots of interesting features like SSL, you might expect, plus some compression ones. There are some compression algorithms in this list, like gzip and Snappy and LZ4 and Z standard. These are all the available compression choices. And the way you configure it, once you know that, is super easy. You just say compression.type is gzip. And then that will do it. If I run that to show you, before our batch sizes were hovering around 150, 200K. Now they are being gzipped and they're hovering around 15 to 20K. So that's an order of magnitude difference for one simple setting. It's a good deal. What are we losing for that? We are spending time compressing. So we're trading off some CPU time for better network usage and better disk usage. And given how fast compression is and how fast CPUs are these days compared to networks, I think it's a good trade-off. It's not set by default because it is a trade-off, but I think it's a good one to just enable some compression. So the question becomes, which compression algorithm do you use? Do you use gzip, Snappy, LZ4, or something else? The answer is, it depends. The answer is always it depends. Some of these algorithms are much faster, use less CPU. Some of them produce much smaller batch sizes. You've got to measure and you've got to ask, how important is it to get the most efficient algorithm? But the one thing you have to ask, which people often forget in these discussions, is not every client library supports every compression type. So I know that Kafka.js, the JavaScript library, supports Snappy but doesn't support it out of the box, for instance. So if I was in a mixed language team and I set my compression type to Snappy, it might be a good choice, but I'm going to have to teach the JavaScript team how to read the data back because it's not going to work automatically. I think always measure, check, think about it. But if you want an easy recommendation for ASCII data, gzip's fast and it's pretty much universally supported. So that is the fire and forget answer. It's worth saying that you can freely change your mind on this. It's cheap to change. If you spend 2 weeks writing uncompressed data and then switch to a week's worth of gzip data and then switch to Snappy, the data on disk won't change. That will always be compressed the way it was originally compressed. But the client libraries will deal with it seamlessly. As long as they can read that compression type at all, they'll just transparently switch on each batch without you having to worry. So you can play around with this setting and see what works best in production. But to wrap up, if you want some quick advice, have a look at this. Measure first. Look at those 3 parameters to actually see what statistics you've got. If you want to set linger.ms to something reasonable, the cognitive science definition of quick isn't a bad answer. The batch size by default is actually 5 meg, which, depending on your system, that's probably the most sensible default of all these defaults. And I would definitely set compression type if you're dealing with readable strings, probably to gzip and just fire and forget. So that's it. That is Efficient Producers 101. And with that data from GitHub stored, the next video is going to be about slicing, dicing, filtering, and grouping by interesting data. If you want to catch that one, make sure you're subscribed to the channel. If you enjoyed this one, please leave a like, leave us some feedback. If there are requests to go over specific features, send us a comment. You'll find all this source code in GitHub and links to the quick CLI app if you want to install that. But for now, thanks very much for watching.